again, this is sample physics here again, and I'm making this clip because students have asked me between the difference between alpha, beta, and gamma radiation, and which one poses a more of a danger to humans or living biological entities. Really, it's important to understand first of all how alpha, beta, gamma radiation behave when it's basically traveling from A to B. Now, when we look at alpha radiation is simply looking at a helium nuclei, which is basically made up of two protons and two neutrons. And it's also a very heavy type of radiation as well. Now, this radiation in particular is very heavily ionizing, and what I mean by heavily ionizing is that it actually is stopped very easily in air in a very small range of distance. And what happens is that when alpha radiation actually stopped, it passes on its energy to other atoms within the air. As a result, it knocks out electrons in the surrounding air atoms. As a result, the atoms become charged. Now, if you take the same example again, and for example, if a person unfortunately, obviously, consumes accidentally a radioactive source, now that damage is also going to occur within the human within our in our bodies as well. And as a result, we are going to get heavy ionization taking place within the body, and obviously that's going to cause a lot of damage as well. So another aspect of alpha radiation is that alpha radiation can quite easily be stopped by your hand, and if it is stopped by your hand, it's very important to understand the fact that this energy that is required in order to stop the alpha radiation is actually then passed on to our hand. As a result, our hand is going to obviously suffer damage due to the alpha radiation. Now, when we look at beta radiation now, however, beta radiation is slightly different because beta radiation is really, was looking at GCSE level, we're looking at really fast moving electrons. And these fast moving electrons are really a lot more penetrating because they can move through more of a distance. However, these fast moving electrons, which is beta radiation, can actually be stopped by aluminium. So aluminium actually stops beta radiation. However, it does not allow another form of radiation to be stopped at all, and that is looking at gamma radiation. Now, students have asked me in a class, okay, looking at the difference between radiation, and they've asked me the question, which one is more damaging? Well, it depends on really how the radiation is exposed to obviously the body, for example. Now, obviously, looking at alpha radiation is heavily ionizing to any surface because it can be stopped quite easily. Now, but if you look at gamma radiation, some students think that gamma radiation is going to be more damaging. Well, if you think about gamma radiation, it basically is pure energy. It's moving in the form of electromagnetic wave, and it's moving at the speed of light, which is 3 times 10 to the power 8 meters per second. And because it's moving so fast, okay, it's actually moving so fast that it doesn't really give time to actually pass this energy on to any surrounding atom because it's moving at light speed. However, there is a problem which is obviously important to consider. Now, if any one of those forms of radiation pass through our body, for example, in the case, let's say beta and let's say gamma radiation, and unfortunately, let's say, unfortunate situation could be if it strikes one of our cells, in particular, if it strikes DNA in the cell, it can cause two things. Number one, it can cause a double strand break, sublethal damage, where the nucleus actually becomes impaired. What I mean by impaired is that when the cell tries to repair itself again, but because the genetic material of that cell now is compromised, it will, in a sense, produce faulty cells. Now we're talking about tumours here. And this is one of the ways that basically how cancer is induced. because the fact that radiation actually, unfortunately, is energy is passed on to the actual nucleus, and obviously the nucleus causes damage. In most cases, what happens is that the gamma radiation actually passes through very easily. It doesn't really strike any nuclei, okay, a nucleus of the cell, and therefore it's going to be less dangerous. So if we now then look at gamma, beta, and alpha radiation, these are some of the things that we need to consider. How, why, which radiation is more dangerous? How can radiation exposure be limited? And there's three different ways that radiation exposure can be limited. It's called time, a time which we are exposed to radiation, distance, the distance, if we maximize the distance between us and the radiation, that is obviously going to reduce the exposure to our bodies. And there's also going to be another one called shielding effects. Now, shielding effects is something that some people see when they go for an x-ray, because when we look closely at a window or a screen in a hospital where the x-rays are, it's normally lead lined. The doors are also obviously lead lined in between the door. It's just the door panel itself. So lead is a very good effective way of actually reducing the intensity of gamma radiation, and therefore reducing exposure to the human body or any living organisms as well. Right, this is enough from sample physics right now, and I will basically follow up on the next topic in another clip. Many thanks.